Hi, I'm Art Nash with Rich Seifert, University of Alaska Fairbanks Cooperative Extension Service. The Cooperative Extension Service brings relevant research from the university to the common resident to help make their life more self-sufficient. Today we're going to go ahead and take a look specifically at some fairly simple methods in which you can make your home more energy efficient.
As you can see, there's a house behind us that is going to be converted from a summer house to a permanent living house for the Fairbanks climate. We're going to look at it, diagnose what the problems are, especially look at air leakage, try and make it as efficient as possible, knowing how to bring it up to a more comfortable, more affordable living space with the least cost methods that we can find.
With that, let's go take a look.
Okay, now that we're inside, we're going to start to look at air leakage and look at where the air might be leaking out and leaking into the house and try and plug those and see what we can do to make the house more efficient from an air leakage point of view. The important thing here is that mostly that's regarded as a problem. Seal up the small leaks and everything will be fine. However, we have to allow some air to come into the house, to be exchanged, to keep the air in the house fresh. And we have to allow some air exchange or the house will become stale and unlivable and air quality will decrease. So we're going to look at places like under the threshold of the door, where air leaks in the bottom of the house, around the windows, on electrical outlets, and perforations in the wall for plumbing. In the ceiling, a very important thing, putting a good air leakage control barrier, a vapor control barrier at the ceiling is very important for weatherization and very important for getting control of air leakage. And it may be that we tighten up the house enough that we may even need a ventilation system, a mechanical ventilation system, to give enough air for the inhabitants to be comfortable and healthy with the air quality that's in the house.
Many modern homes, in fact most modern homes that are built by contractors, almost always have an active ventilation system. Usually in the northern climes, heat recovery ventilation systems are used. Though they're relatively expensive, one of the advantages of having a heat recovery ventilation system is that it can provide balanced airflow through the house to ensure that there's fresh air entering with stale air leaving, and yet the heat is recovered from the exiting air and given to the air coming in.
I'm standing near an open window on a beautiful sunny day. It happens to be April. And you can see that the window is open, which is a standard form of passive ventilation. And it's a system that we've been using in housing in the United States and in Alaska for many, many years. But we're finding that we're getting to a place where not only is this a bad idea in the middle of winter, as anybody who lives here can tell you, but it is not going to be adequate for most of the year. And we want to make the house a lot more effective with controlled ventilation. There is a physical process that goes on most houses called stack effect, where air tends to leak in low in a house and leak out high because we're adding heat to that air as we bring it in. We heat it with whatever system we're using to heat the house. This house has both baseboard heaters and a wood stove. And as that air is heated, it tends to want to become buoyant and move upward. So you have this general pressure to move air out of the house high and into the house low called stack effect. Well, stack effect works really well in moving air in and out of the house. In fact, it works a little too well. And consequently, when you have very, very cold temperatures outside and you're heating your house maximum, you tend to enhance the stack effect, and air leakage becomes a really big factor in heat loss. So once you get a control of heat loss through air leakage, you can much more manage the energy conservation and heating of the house. It becomes less expensive, and you also can control ventilation and may want to move toward the heat recovery ventilator, which is mentioned earlier. But getting control of air leakage, getting control of the stack effect is a crucial factor. Once you get control of it, then you can apply the heat recovery ventilation option. But if you don't get good control of air leakage, the ventilation option is moot, because there will be so much air leakage when it's very, very cold that you can't overcome what you're losing too fast by this leaky old barn that you have, that you can't add enough ventilation to make a difference. So the house has to be worthy of ventilation before you apply it. Almost all the fuels we use in our heating of our houses today are carbon-based. Even if you're using wood, even though it's not a fossil fuel, it still burns essentially carbon and produces carbon dioxide. All the other fossil fuels, coal, oil, gas, are carbon-based fuels. And so as long as we are using carbon-based fuels to heat our houses, there is a chance, if things go wrong, that we can produce carbon monoxide in the houses. And carbon monoxide is one of the single most dangerous poisons that ever can be in your house. It is you cannot sense it, you cannot smell it. It is entirely impossible to know it's happening. And the worst part of carbon monoxide is that you become starved of oxygen and lethargic, and you lose your alertness, so you can't always tell when something is happening to you. So we highly recommend that everybody have a carbon monoxide detector in their houses. It's very, very good insurance. It's not all that expensive, and even the weatherization program now gives a carbon monoxide detector to every house they weatherize for safety purposes. One more thing is, we often get questions in cooperative extension about where to place these. It's not an easy question to answer. Some of the simple answers are between where you're sleeping and where the most likely appliance is, which could give you carbon monoxide. That's pretty much for the homeowner to decide. But one of the things that's key is that the carbon monoxide will be a combustion product. It will be warm gas. It will tend to be buoyant. So you don't want to place this low in the building. You want to place it at least chest high or arm height. That's about the best recommendation I can give you for that. One more thing that I want to make sure you know. All carbon monoxide detectors have a limited life. The detection technology that's used does deteriorate with time after about 4 years. So I recommend whenever you buy a carbon monoxide detector, you turn it around on the back and you write the month and year at which you purchased it. And hopefully 4 years from that time, you will look on there and you'll say, it's time for me to buy a new one, because it will become unreliable after that point. And one more feature, I highly recommend that you get a battery operated carbon monoxide detector, because it's very much more likely that you will have a carbon monoxide incident if you're in operating conditions which are emergency. Say the power is out in your house and you have some other option for heating that may be a source of carbon monoxide emissions. You might want to have a battery detector that operates in that condition and lets you know that there's a problem. With a power plug-in model, that wouldn't be possible. So double good is to have a battery type carbon monoxide detector. Okay, now it's time to look more closely and see if we can find out where the air leaks are in this building. And we did a little preliminary seeking here, searching out, and we found that this little line, which is almost really hard to see, I think probably in the camera, but there's a seam in the window here which is separated, probably a little bit of shrinkage of the wood over time, and you can actually see daylight through this. And so one of the ways we could seal this presents a problem because it's a finished piece of wood, but you could caulk it with a very thin bead of, say, transparent caulk, and then cover it with a nice piece of trim. And that's one air sealing place which we could scrutinize and look at very carefully. So that's what we're going to do next, is look around the building for places which are obvious air leaks that we can work on.
Similar to how Rich went ahead and through mere observation and sunlight found cracks between the window casings, I'd like to check the other natural opening in a home, which is the door. Now with the door, we can take a dollar bill, open it up, place it, so that we have it curling around to the front. If we then tug on the dollar bill and it slowly comes out with some resistance, we know that that's probably a pretty darn good seal. We can also do the top of the door. And again, there's proper resistance and yet no tearing or no pinching. However, when we come to the bottom of the door, you'll notice that in this situation, there's been paper towel that's been placed. That has been put there because mosquitoes were coming in. We don't even need to check with a dollar bill if the mosquitoes are coming through. So we'll take care of that problem later with a very quick and easy type of material at another time. Let me add that in a home where there's a bathroom fan and a range hood, possibly even an electric dryer, if all the items are turned on at once, thus pulling air out of the house, you can go ahead and wet your hand with moisture and just feel right along the edge and see if that pressure that's being created internally through those fans is pulling or rushing air past your hand. This shouldn't happen. Another easy way to take a look at it visually is to go ahead and get a punk or an incense burning stick, light it, and hold it next to the door, again with all the fans and the dryer on. This will help you to see how fast and also in what direction the smoke is going. Obviously, it should be pulling due to the difference in pressure of the outside and the inside of the house towards those fans. Rich had mentioned when witnessing cracks between casements of windows, sunlight coming in, that a small amount of clear caulking could be applied to stuff up more or less that crack, and a piece of molding could be applied to the outside. This would of course keep any wind from coming in. Likewise, the other location in the house where there's a large opening that can be open and closed is the door. And in this case, we're going to go ahead and see how to apply a little bit of caulking to reduce the amount of ventilation coming in places where we don't want it. Now, with caulking, there's a whole plethora of different colors, different types, paintable, non-paintable, made up for different parts of your home and such at any building supply store, rows of it. Let me just suffice to say that regardless of which caulking you choose, you really should caulk in the summer when you can ventilate the whole home freely. They all have different ingredients that really should be avoided from any type of inhalation. Once the caulk is set, after about 4 hours, feel free to come into the home. It's set, it's cured, and the different types of volatile odors that are given off will be pretty much finished. With caulking also, you'll find that there are some brands that may make claims, such as one that I have here, of having 35 years of durability guaranteed. However, we would suggest that after about 5 years, 1 year after your smoke detector has canceled out, that you go ahead and take a razor blade and neatly cut along the edges of where the caulking is adhering to the trim, the wood, the tub surround, and scraping it clean and reapplying caulking again. The caulking that I'm going to use, as you can see, is a paintable caulking, silicone, that's beige. As I mentioned, there's quite a consumer choice out there. Once I've gone ahead and applied the tube into the caulking gun correctly, and I've used the metal shard to go ahead and poke through, I can go ahead and apply pressure and find that indeed the caulking comes out. I find that this is under quite a bit of pressure though, and therefore it'll run even when you're not pulling the trigger. My suggestion, with your thumb, go ahead and release the spring-loaded aperture. Take your wet towel wipe it clean, and now have your hand ready and only apply pressure, even if it's passive, once you have the gun in place. Let's go ahead and lay a bead and see how it comes out. You'll notice that I'm pointing it at about a 45-degree angle from the horizontal and the vertical surfaces of the walls and the floor, and lightly just applying a small bit with the nozzle and pulling it evenly. It's very difficult to get it perfectly evenly, but we're going to go ahead and take care of that in a moment. I release the pressure. As you'll notice, we had laid a bead along here, and yet there's still some areas up toward the paneling where there's a void. So I'll go ahead and run over this again while gently squeezing on the trigger to apply another bead of caulking. In this particular case, some of it will be subsumed behind the actual siding or plywood paneling. And at this point, again, wetting the finger, I'll go ahead and drag across lightly so as to force some of the caulking up along the bottom part of the paneling. Now, in 4 hours, though this isn't the most beautiful job as far as finishing it, it's probably best to go ahead and have it fully dry and then apply a piece of base cove, a type of trim per se, just to cover over this. We could spend some time adding more caulking and trying to get rid of some of the bumps and such, but our main goal is to go ahead and fill the void. And my experience with caulking is, as many others have told me through the years, the more you mess with it, the more you're going to probably botch it up and apply a liberal amount which you won't know what to do with.
You can see we're looking at an electrical outlet here, and this is a 2x4 stud wall. And when this wall was built, it doesn't really matter now whether there was good air sealing around this electrical outlet or not, but it's a common place where you have a lot of air leakage because it typically would have been cut out of the vapor barrier and the electrical box would have not been air sealed. So there actually are products available now, and I'm looking at, they come in packets. It's a plastic gasketed material. It has nice little cutouts that you can simply remove like this, and designed to fit right into an electrical outlet cover. And I have to make sure I can get that little hole where the screw is supposed to go, which is not easy to do with the large fingers that I have. And well, I'm still not doing it. Maybe I will just not worry about it. There we go. And let me take the faceplate off of the electrical outlet. Single screw does it typically, and comes off very nicely. And you can see this hasn't been dealt with for a long time because there's a lot of, this is kind of an instructive thing because there's a lot of what looks to be, dust from dandelions and things accumulated here. So there was some air leakage. This has been filtering air for a long time. You simply place the gasketed material in here. Make sure you can put the screw through the hole. Put the faceplate back on. Screw it in place. And the screw is nicely placed there. It's even in the hole, and voila, you have made a very good gasketed airtight seal. And you can use these. They come in packs of, it looks like 6. And you can do usually a house, depending on how many outlets you have, in short order. You might want to, for safety purposes, turn the power off so you don't accidentally put the screwdriver in the wrong place and have a bad day. But otherwise, very easy to do and fairly durable. Once you put that plastic gasket in place, it's out of sunlight, should last a very long time and be pretty good gasketed seal.
So the one place in your home where you're constantly opening and closing encasement is your door. Now, doors over time, though you may have set them well and they were snug against the door jamb, may end up developing cracks. You may get a warping of the door of the jamb, and you may find that the seal is not tight. The air will infiltrate through certain portions of the jamb. It used to be that you would take a piece of thin felt, line it up, and while you were holding it, you would try to take a small finishing nail, and half the time hitting your thumb, nail the nails through and snug up the felt. However, today we have a much more efficient material that we use that's made out of rubber and is almost like a gasket. And this material usually comes in a row. Originally, it was the width of both these pieces in case the jamb was 3/4 of an inch wide. However, as you'll notice on this older jamb, I don't need both pieces. So I've merely found the scoring and separated them. The other convenient aspect of this material is that with a simple pocket knife, I can go ahead and make a slice and adjust the length. So at this point, let's go ahead and apply what I have. I'm going to go ahead and first wash the surface off with a damp napkin and then wipe it with the dry end just to make sure that dust, cobwebs, other things that may have developed come off clean. You can see the accumulation right here. That would inhibit the ability of the adhesive from sealing well. Let me mention also while I clean this that though the adhesive is fairly sticky and it's a fairly strong tape, to make this last, I would obviously go ahead and try different types of maybe glues. And every 3 inches or so on the back of the gasket material, put a dot of glue. Now, I'm simply going to go ahead and fold this back. And as I go, I'm going to go ahead and unfurl the protective layer. I want to make sure that this is fairly snug, not only flat against the jamb here, but snug up against here. So I will find a point, pinch, and when it looks like everything's snug, I'll firmly apply pressure. I'll go ahead and pull the tape. I'll find a point with some tautness in the gasket, push down, apply pressure. You can see that this is much easier and not as time consuming as using a hammer with a type of flexible material like felt. The nice thing about this material too is that you can paint over it if you want to. And in addition, if you need to cut out a certain portion because of part of it starting to get worn down or starting to break the top surface due to maybe irregularity in your door, you can cut that piece out and put a new piece in. Applying pressure. Again, if I had a certain type of adhesive with me, every 3 inches I would put a dot of adhesive. Now in this situation, I want to miter or come in at an angle. So with my knife, I'll go ahead and simply saw off the residue blocked piece of gasket material. making a 45-degree angle. Coming back in and overlapping slightly this gasket material, I can apply and put it in. And as I mentioned, one of the advantages is that even though my strip was not long enough in this particular case, I can go ahead and take off of the other strip now by measuring and simply slicing and adding a piece in there. Here you have a mitered corner. Now, even though I still have some to add here for now, really the important place that I want to test and make sure that the gasket material isn't going to be too tight is down by the strike plate. So I'm going to go ahead and shut the door, and we'll see if there's somewhat of a sponginess or a give, and whether the door fits snug and yet not too tight. Let's take a look. Now I should be able to simply apply a little bit of pressure to the left or the right, and it should open right up. And having said that, let's see if it's secure against the door jamb. Not much give at all. Now I will go back with a cutout piece and just add this in.
Here we show, remember now we're converting a summer house to a winter house, and the summer house has single pane glazing. And that's going to be fairly nightmarish in the winter. Now we're going to show you how, with a product that's available almost anywhere in Alaska, in all of the building supply stores and hardware stores, that you can take a plastic material, add it as a second pane effectively of glazing to a window, and have three good things happen. You'll have an effect of insulating the window as though it were now a double pane system. You can do it with, if you're lucky and the framing of the window is correct, you can heat shrink it, make it very, very tight and look almost transparent with very little distortion, just like a good window. And thirdly, it has the additional advantage that you can seal around the edges such that no moisture can get to the window surface and you don't have condensation problems. So Art is going to take it now and show you how to tape around the edges. He's already done some of that, and he's going to tape the final layer, and then we're going to hang the material and show you how to do it.
So I just want to emphasize, as Rich said, this is fairly easy. This could be done with one person, as we'll show when we hang this, that the film actually, through static electricity, will cling to the window. However, we're going to go ahead and have the both of us work on this. The kits usually come with the actual film as well as a double-sided tape, rolled double-sided tape. Now, similarly to our job with the caulking in the kitchen, we've gone through and we've basically gotten a wet towel and we've wiped down the edges of this molding, which is protruding from approximately half an inch, and we've applied the tape, which is sticky on the one side, all the way around the outside of this molding or casing, and we'll do so here. And in the end, this lip on the casing is going to be our sealant for the film. Now, you have to be careful to make sure that it's all within the included area. And you can always pull back if you make an error, so don't be afraid to go ahead and apply it the first time. So in this case, just folding over a corner and trying to separate the tape from the wax paper may be the most difficult part of this project. You may need to have a razor blade handy to try to stick it to the inside of the tape and pull it away from the wax paper. In any case, I have this started. I merely remove the wax paper And it's on this sticky surface then that we'll go ahead and apply the film with a small overlap. We want to do the same not only on this edge, but also by grabbing the bottom piece of tape.
And the side.
And then pulling on the top. At this point, we have the edges prepared, and now we want to go ahead and lay the film. What we don't want to do, however, is to go ahead and haphazardly take the top of the film and lay it down on the sticky portion until we've made sure that we have the sheet of film equitably distributed so that there's at least an inch of film on all the sides. Therefore, Rich will pick up one corner. I'll pick up another. If you were doing this alone, you could get away with it, because before actually taping the thing, you're going to go ahead and merely push the film against the glass, and you'll notice that the static electricity is usually sufficient to hold it for you until you can go ahead and measure and make sure that you have that overlap. And Rich, I have about a ½ inch here. How about you?
I have, oops, it's sticking, oh no. Okay, I have that, adequate, certainly adequate. It's a little, oh no, I need a little more on the bottom.
Rich, I have about a ½ inch. How about you?
I need a little more down here at the bottom. I'm okay now. Okay.
At this point, we can go ahead and start to
Seal the top.
seal the top. You'll notice that there are lines from the folds of the film. That's nothing
And
to
the
worry
side
about.
now?
Yep. We want to get it taut as we can, but we won't be able to necessarily at this stage bring out those lines in the actual film. We will, however, though, try to make sure that equally across the surface we have about an inch gap between the film and the window. And now together, let's tug on the bottom
Okay.
as best as we can, and then just run our
Why
fingers.
don't you come toward me and I'll just hold it
All right.
so I don't crimp it in the middle. Not terrible.
At this point, Rich and I have now applied the film to the surface, and we're going to go ahead and tighten it up. We'll create a taut surface by applying heat that will then cause the film to become tight, such as the head of a drum. We'll want to go ahead and turn it on high. We'll want to make sure that the end of the hairdryer is no closer than an inch from the surface of the film so as not to burnish it or cause puckering. And we'll want to go ahead and, in a circular motion, move across the window, applying the heat as evenly as possible. Let's give it a shot, see what happens. You'll notice that the wrinkles are dissipating as the heat goes over. Nice and even. Again, no closer than an inch to the actual film itself. notice at this point that if you press on the surface itself, again, it's as taut as almost the head of a drum. Now, you'll notice that there's some gapping here. And this is something that you'll want to make sure to go ahead and shore up and try to tighten out, as we want to make sure that there is no air pocket that's coming through the actual tape where the plastic possibly hasn't been adhesed all the way down onto the tape. Again, your wrinkles are gone. At this point, just for cosmetic purposes, you may wish to go ahead and take a pair of scissors and just score the plastic right above where the molding intersects the paneling. You want to be careful though, however, to not snip such as this, where you might pull on the tape, but merely grab the plastic lightly, having your scissors half open and running them across the top, or possibly using a razor knife. At this point, as Rich had mentioned, in effect, you've actually made a 2-window-pane window with very little effort. So you've seen several situations in which we've gone ahead and sealed up cracks or holes and such to go ahead and keep air from infiltrating into the house. There's one other product that's fairly popular, but you need to use it with caution, let's say, and that is spray foam. Now, some spray foam, when you apply it, the volume that you apply, you can be assured, much like with caulking, that the bead will stay that size. However, there are other spray foams that may expand to several times the size of what you've applied over the next few minutes. On the back of this can, it's demonstrated the before shot of a channel and how much foam would be applied. Notice that it is not covering or filling in the edges. But then after some amount of time, what the after volume will be. This is pretty important so that you can be sure to go ahead and adequately fill the void, but not cause undue pressure in the void that might go ahead and cause rupturing or possibly pressure around the edges of whatever hole it is or crack that you're working with. So the other thing that you want to be sure to be aware of is that this is incredibly sticky material, and therefore whenever applying it, in this case you would remove the lid, you would simply apply the hose with the trigger piece onto a stem, and you would pull the trigger and it would go ahead and fill the tube, evacuating the material. Whenever doing that, you would want to use some type of latex or plastic gloves. The reason being is once this is on your hands, it's incredibly difficult to remove. In fact, it will harden like a cake, and you almost have to pry it up sometimes with a razor blade to separate it from your skin. Very effective material as far as filling voids, as far as keeping circulation of air from happening, but it has its use for the most part on a framed house where there are large gaps and large cracks.
Well, it's time for a few good words about choices of light bulbs. We don't have too many pieces of advice, but I'm holding here in my left hand something that's probably familiar to you all because you are tending to buy one simply because its first cost is less, it's cheaper. But you will spend a whole lot of money for electricity using this 60-watt bulb, this incandescent bulb, to heat your house rather than light your house, because 90%, 9 out of 10 watts that goes into this bulb comes out as heat, and only it gives light off as a side effect of the incandescent feature of the bulb. So we have actually had engineers and companies produce bulbs now that are in fact, this one is about 4 times more effective at using electricity. And that's a pretty good number for all compact fluorescent light bulbs, which is what this is. It's one of many styles. But compact fluorescents are fluorescent bulbs, but they use energy to produce light. They use electricity to produce light at about 4 times the rate So you get 4 times the amount of lighting, the lumens, out of a bulb for the same expenditure of electricity. This is a 13-watt bulb. It's equivalent to this, to a 60-watt incandescent in the amount of light it gives off. And this can be measured scientifically. So this one will cost you over its life 1/4 of the electricity for the same amount of time that this one is burning, giving you the same amount of light. The only difference, of course, is that this bulb costs more, but it is much more cost competitive than it ever had been in the past. And that's why some people are reticent to do them. These come now in 6 packs. You can buy them in bulk, and they're very, very effective. One more extremely interesting and now coming into its own technology that has been developed is one I don't have an example of, and that's the LED. It is even more effective in the long term, and unfortunately a little more expensive for the same output of light. However, its lifetime is about 4 to 5 times typically what the compact fluorescent is. That's a key thing. Lifetime of incandescent bulb, typically 1,000 hours. Lifetime of compact fluorescent bulb, typically 10,000 hours, 10 times as much. Lifetime of LED bulbs, 50,000 to 100,000 hours. So up to 10 times as long as even an incandescent, or as a compact fluorescent. So the technologies are getting better, the prices are becoming more competitive, and it's getting to the point where you can get an extremely efficient bulb that you may not ever have to change in your lifetime, which is a really nice deal. So that's what we need to talk to you about in light bulbs. Always go for the most efficient in time. So if you'll notice around this building, we have compact fluorescents, we have incandescents, and we have long tube fluorescents. Long tube fluorescents are getting more efficient. There's a tendency to shrink the diameter of them. They often will need a new ballast, but they are getting more efficient too. There's something called a T12 that is the standard 1.5 inch diameter tube. You can now get a T8, which is about the same output for the same wattage. I mean twice the output for the same wattage as a T12 was. So even the compact fluorescent tubes, you can use the same fixtures. You just need a new ballast, and you can actually improve their lifetime and their output per unit watt electricity as well. So good to think about. We need a lot of light in the winter in Alaska, and now there are technologies that are giving it to us. Better light for longer periods of times at a lower cost per output.
Well, thank you for joining us for this short amount of time and seeing some of the energy saving methods which you yourself can employ in your own home.
And we've shown you the ways to do it now. We've shown you what products are available. It's up to you to help yourself now to a better life and low energy costs.